Hi, I'm Kristen Shinohara from the Rochester Institute of Technology, and on behalf of my co-authors, Junchen Lee and Garreth Tigwell, I'm presenting our paper, Accessibility of High-Fidelity Prototyping Tools. High-fidelity prototyping tools enable user interface designers to quickly mock up interfaces, which can then be used to gather feedback and, during testing, to identify any usability and accessibility issues. Screen readers are tools used to read screen content out loud. Screen readers are often used by blind and low-vision computer users to access screen content. For example, we show here a screenshot of the Wikipedia page for Google. A screen reader might read the title of this page out loud as Heading Level 1, Google. Increasingly, there is a drive to ensure that user interfaces can be used with a screen reader. But how accessible are prototyping tools for people who use screen readers and wish to design user interfaces? We conducted a study to examine screen reader compatibility with prototyping tools. Specifically, we sought to know what parts of prototyping tools are compatible or not with screen readers, which tools are recommended for use with screen readers, and what accessibility issues arise when using these tools together. There are a variety of screen readers and tools available. We tested how well VoiceOver on the Mac and Narrator from Windows worked with the prototyping tools SIGCHI, Adobe XD, Balsamiq, and UXPin. We assessed how well the screen reader could access GUI elements and controls, and how well tasks could be completed toward creating a simple prototype. For example, would a screen reader read aloud the function of a button and accurately provide information about what is happening on the screen? We found that Balsamiq had the best screen reader compatibility, but that overall most tools were not accessible by screen reader. In addition, most issues were compounded by multiple problems. For example, 42% of buttons were accessible, but most did not have labels or had incomplete alternative text, often making it impossible to know what the button was for. Another example was poor focus order. For instance, a user may create an element by selecting an Add Shape button. After selecting the button, ideally the system would move on to select the new shape element on the canvas to aid with quick editing, but instead the system remains focused on the Add Shape button. We attempted to create a simple prototype using screen readers. Across 6 different tasks, including creating elements, adding them to a canvas, renaming a canvas, and editing parameters, we assessed how well we could complete each task. Overall, we were unable to complete about half of the tasks, which amounted to failure in creating a prototype with each prototyping tool. Task analysis uncovered situations where multiple accessibility issues prevented 100% completion of any given task. For example, it was difficult to create elements because many were not operable by keyboard, or it was difficult to move elements due to lack of information about sensory characteristics, such as the element's shape, size, or location. Finally, all tools failed to export prototypes. Our analysis determined that VoiceOver and SIGCHI had the best compatibility with the second best conformance to accessibility guidelines and the highest task completion rate. However, for practical purposes, Balsamiq was more efficient because it implemented templates that eliminated many steps that created problems for other tools. We found that while prototyping tools have some level of screen reader accessibility, they are not yet accessible enough to enable a screen reader user to effectively and efficiently create high-fidelity prototypes. Based on our analysis, we recommend that tool improvement should prioritize accessibility of individual widgets, such as the canvas, buttons, text fields, and should focus on addressing accessibility issues for individual tasks, such as focus order, input instruction, alternative text, or keyboard operations, to name a few. Our findings will inform future improvement in high-fidelity prototyping tools to better support designers with disabilities and toward improving the overall accessibility of interfaces. We look forward to your comments and questions. Thank you.